So this idea here where we're just adding the waves or subtracting the waves to see what the resulting wave is actually called the principle of superposition. And that's how you figure out what the resulting wave is going to be. And so we're going to write out the principle of superposition here. It says when two waves are at the same point, the displacement of the resulting wave is the sum of the individual waves. That's the fancy way of saying add them up, okay? So in other words, add them or subtract them like they are numbers, okay? And so now we have a bunch of practice that we're going to do here. And we've got our first example is very similar to the first one that we did. We have a 1 wave and a 2 wave. And when they meet, what do you think they're going to make? Well, if you were guessing a 2 wave, then you're right. So is that going to be constructive or destructive interference? Well, it looks like they're getting bigger. Okay, so this 2 is definitely bigger than both of those original waves, and so it is constructive interference. So let's look at another example. So now we have a 1 plus a 2. And what is that wave going to look like when they meet? Well, that's going to be, oh, I got an extra little bulb there. We've got a 3 there. That wave is definitely bigger than the original 2 waves that we have. What is that kind of interference? If you said constructive, you are right again. And now I've got my third example. Now I have a 1 and a -1. That -1 is down on the bottom. I put a negative there because it's like a hole in the ground, okay? And when those waves meet, this one's a fun one. What are you going to write in that what they will become box? Well, if you drew a flat line, you are right. Those cancel completely out. If this were sound, you would hear absolutely nothing. And if this were light, you would see absolutely nothing. Okay, this is something that cancels completely out. This is definitely destructive interference. There's nothing left after that. Okay. For our fourth example, now we have a 1 and a -2. This is the one that we did in the previous one, so you already know the answer to that one. It's -1. And this was our example for destructive interference, so you know that one is destructive. And what do you think about this one? This one might be kind of hard. So we've got a -1 and a -2. And if you guessed that this one is a -3, then you are right. But is this one constructive or destructive? Is it getting bigger or is it getting smaller? And how do you know? So we have to think about this one in terms of amplitude. Amplitude, remember, is how big it is or how far the maximum displacement it gets from that equilibrium position, that middle line. So we've got the line here. This line right here is the middle line. So it's getting farther from that line. This wave is actually getting bigger. So this is definitely constructive interference. It is getting more negative, but it's a bigger number. So we have 1 and 2, and now we have 3. This one and this one are very similar. It's just getting farther down instead of farther up, but it's still constructive interference because it is a bigger amplitude. Okay, it's about the amplitude. So in your packet up next, you'll have some practice to try. These are actually kind of fun, where you have to put those waves together and see what they meet. There is a website linked in Schoology for you to play with, so that you can actually try those and watch them come together and pass each other up. It's really entertaining to watch waves interfere with each other. If you have any questions, make sure you ask your teacher. Thanks for watching.